Welcome to the Advanced KML session. My name is Bent Hagemark. I have a couple of announcements first as people filter in. We will have 2 session changes, it says here. We have rescheduled surprisingly rockin' JavaScript and DOM programming in GWT. It will take place at 2 o'clock p.m. in room 9. And we will repeat this session, not this one, but the session, Building a Scalable Web Application with Google Apps Engine at 12:45 in room 8. And all sessions, excluding the fireside chat, will be posted by mid-next week on the Google I/O website. And there are surveys here for you to fill out and drop in that box back there. All right, we'll just jump right into it. How many people here know what KML stands for? Excellent. How many people here have entered in live KML? You know, Placemark and folder, NetworkLink, and okay, for those of you that don't, no problem. KML stands for the Keyhole Markup Language. And I hope we haven't scared off too many people by the advanced subject. But we'll go right into it. This is what I'm going to talk about for the next 45 minutes or so. We're going to take some questions at the end, and so get ready to ask some things. We going to do a little demo as well. Demo God's willing. So 4 subjects for this discussion today. We're going to talk about the OGC standard. We're going to talk about the architecture of KML. We are going to go into some very specific advanced feature tips and tricks learned from yet another year of working with all these cool things. And then we're going to talk about some ways that KML goes in the future. All right, the OGC. How many people here are familiar with the OGC? Excellent. The OGC is the Open Spatial Geo Consortium, and as of April 14th, 2008, a little over a month ago, the KML 2.2 specification survived largely intact and is now well within the domain of the OGC, where we as a company and many other organizations that also actively use this language are also quite active. Somebody's coming up here and adjusting me. I'll keep talking. Are we doing okay? All right. We, just to sound really official, we have an official standard number, -070147R2. That is a document. There is a corresponding abstract test suite, which has a nice number as well. The important thing about this, from everyone's point of view that's worked with KML before, is that it's 100% compatible with all the KML you've ever seen. Everything that was in KML a few months ago is in OGC KML. All of what you can see in OGC KML specifications work in Google's products. One minor difference is the official namespace for the OGC standard is the string that's on the screen there. And here are some links. When you are able to access this, you'll be able to click on these links and go look at these websites for yourself. I'm actually going to show you my favorite page on the entire internet. This was actually quite a thrill for me. This is the formal schema of the language, the formal definition of the language. It is now hosted at the OGC. And this survived basically largely intact from what we developed inside Google. Okay, KML has an architecture. There are approximately 150 some specific elements in the language, but they all reduce to being some variation of these 5, 6 concepts on the screen here. And I'm going to talk very quickly about what they are and how they relate to the concrete elements. When I speak about KML, the reason I bring this up is because when we speak about the advanced features of the language, it's important to understand these various classes of elements. And they are the object, feature, geometry, style, link, and something that's new with the standard is the extension mechanism. Okay, object is what gives every complex element, almost every complex element, it's ID. This is a unique value as per XML specifications. This is a pretty important concept, given that that is what identifies a given object, which could be a feature, it could be a container, for purposes of update, which we're going to take a look at, as well as for style referencing and a couple of other interesting features. Feature is what endows, is the holder for the balloon. It's the left panel entry. It is what operates, what the user operates on. It's their unit of visibility. It's a viewpoint. It's it's where styling is located. And there's some custom data, which I'm going to talk a little bit more about. And I'm noting here sort of the formal name and the specification of these. These are all defined in the spec, and if you go to, I think, section 6.1 of the OGC specification, you will see this architectural model. Of course, the concrete elements are the ones that you might be more familiar with: Placemark, network link, the containers, and the overlays. They are all features. So every one of these is something you can fly to. Every one of these is something that has a balloon. Every one of these is something that can have a time. Every one of these is something that has a separate visibility control region. Again, so when I speak of these advanced features, I'm speaking of them as a class of operations on these things. Geometry, of course, you can draw things. That's somewhat the main point. You can draw in 2D or 3D. And they are these elements. Model is a little bit funny, but it's in there. And one note about multi-geometry that I see often is misunderstood. If it has an interesting purpose in that, say you want to control the visibility of multiple geometries, you want to have a point, a polygon, a line, and you want them to all go along with a visibility check or a region, then you can put them all inside the same placemark. You want to have them all go along with the same balloon. You put them inside of a multi-geometry and give that to the placemark. Style is a very important concept in the language and its structure. There is an element called style, of course. By style here, I mean sort of style in quotes. An advanced technique in using styles is to share them, and I'll show some demonstrations about how we do that for the data sets that we publish. And again, that gets back to the ID, and it gets back to this happening on the granularity of a feature. And once again, I give the formal name in the specification just to ground this in the standard. And here are the elements that you have undoubtedly worked with. And then finally, link. Link is the concept basically of linking to stuff. You can, of course, fetch more KML using the href when it is a child of link inside of NetworkLink. You have the overlay icons, images. You have shared styles. You have schemas, which can be network shared, and all the things mentioned there. The final one, description, is something we added in 2.2 for, it's the atom element used to provide attribution. And there's a link there. That link is the only one that's not active. Everything else in the language is a link that is actually fetched. And here are those elements. Now, one question is, when we have a standard that is now owned by the OGC, what happens when we want to add stuff, change stuff? Well, we thought pretty long and hard about that. That's something we actually spent about a bit of time working on with the OGC and is in the formal specification. And there are a handful of answers to that question. So depending on what you mean by extension, there's kind of two ways I think about the kind of things that show up in a KML file. One is the stuff you're going to draw. You have the overlays, the points, the geometry, the things that take actions like the network link, the stuff that all does something. And then you have what you would think of as being the more annotative elements, such as the name, the description, and beyond that, depending on your data set, you might have, say, a golf course, and you want to put the par of the course and the length in yards and the handicap, or whatever, or as a trail map. You want to have the length, and you want to structure this data for possibly your own purposes, or you want to put that into a balloon template, which is something I'm going to show a little bit about that we make pretty heavy use of. Then you want to be looking at doing extended data. That's not an extension of the language, that's an extension of the annotation that you can yourself add today. And the extended data allows you to do that in a typed and an untyped fashion. I don't know how many people here have worked with the schema element from the old days. In KML 2.2, it's been slightly repurposed in that schema describes a type. You can define a type in schema. The instantiation of that type is as the schema data element in extended data. There is no, we had this subclassing mechanism in the older Google version of KML, and that wasn't very XML proper. So we've rectified that in the standard with the help of our OGC friends. And finally, you can put arbitrary XML in this portion of your feature. And the last is that the language itself has an extension mechanism. Now, this isn't relevant necessarily to developers. It's much more relevant to implementers, such as ourselves and all of our friends who now display KML content and process it. The one key thing that this means to you developers is that, assuming this is used, what it requires use of is namespace prefixing. So that's the short version of how extensions are going to, how extensions are specified as in the standard. So just something to be aware of. Your processing tools, your pipelines, as ours, will need to learn about namespace prefixing. Now, one thing, if you look very quickly through all these slides, I have not shown any angle brackets. I don't know if everybody yesterday went to Michael Jones's talk and Paul Rademacher's talk, where they introduced the plugin to Earth. The XML, that language that you've been working on through the parser and text files and such, is now reflected also out to a JavaScript engine. They are the exact same model. And here's the links that provide documentation for both of those. They're not just the same model, they're the same thing. When you type placemark in your XML file or in your JavaScript file, you are doing the placemark itself inside of the Earth plugin has no idea which one of those has created it. So it's another one of these things we've been working on in the background to architect the language. All right, let's talk about some specific advanced features. First off, we're going to review what the basic features are. And you've undoubtedly worked with these, mark points on the Earth, draw some overlays, organize them into folders, apply various styles to give custom icons and colors to labels. And I consider NetworkLink, we'll call it a rudimentary feature. It's a single item that you can use. I'm going to talk now about some tips and tricks and specific aspects of my favorite 4 kind of advanced features of the language. I always love to talk about region. Time is an interesting one. Update has some interesting applicability. And then extended data. All right, so region is a very big subject. I could probably write an entire book on this. I don't know how many people here have worked with region. Handful? Okay, I want to see more people use it. There's some really cute things you can do, useful things you can do, even if you're not working with massive data sets. We've often talked about this as a way to present your massive data sets of thousands of points, tens of thousands of points, or even millions of points, large overlays, which we do ourselves. But in addition, there are some simple things simple effects that you can achieve with this, even for a very small data set. I'll try to show some of those. And then I'm going to show a little bit about, I'm often faced with debugging. Regions are kind of hard to debug. We have some tools that help with that, and some things that I've picked up on that might be some techniques that you could think about. Region, of course, operates, and now we know the architecture of the language. We can talk in terms of region operating on any feature. If it's a placemark with geometry, that controls its visibility. If it's a network link, that controls how it's fetched. Same visibility and fetch for an overlay. And if it's in a document and a folder, they cascade. So if you have a lot of features that have the same region, you can just put that in a folder and it will cascade into the group. There's very few elements that actually cascade. This is one that does. So here are some of these simple effects that I've been talking about. Okay, so everybody familiar with min LOD pixels? This is the one single most important specific element related to region. If there's one that you got to get right, it's this one. If it's one that if you get wrong, you'll have a mess, it's this one. And in my discussion today, I'm not even going to talk about the geographic extent because for the purposes of LOD, it doesn't matter. This is what controls when your related feature becomes visible depending on how big that thing is on the screen. I don't care if it's the whole planet or a city block or a country. This just says whenever it's that big, I don't care what you are, it's time to show you. So one little tip that I have is that if I ever see a KML file with a min LOD pixels number of anything less than 128, you might be doing something wrong. You have to think in terms of this number is the square pixel area of the screen or of the region. An awful lot of users have displays that are in the 1024 to 1280 type of size. They're pretty small. I know back at work we have these gargantuan dual screen high def monitors. That's not what most people have. Most people have what I'm using right now, which is a 1024 display. And my rule of thumb basically is that a 512 min LOD pixels is, this is my sort of doing regions kind of display here, is 1/4 of the screen. So you can think in terms of when do you want this thing to show up? 512 means it's going to show up when that area occupies 1/4 of the screen. So you want something in the United States to show up when the United States takes up about 1/4 of the screen. Make that region be whatever the United States is, but give the number 512. I've seen people game the LOD numbers by basing their regions and sort of computing wacky LOD numbers. Believe me, it's a lot easier if you keep these things sane and adjust the regions for your data sets. Of course, regions have the second most important aspect of a region is the max LOD pixels. This one I would actually consider fairly obscure. Unless you really know what you're doing, you probably should not use this one. People often think in terms of things popping in and popping out, or zooming in and zooming out. And the region is, of course, much more sophisticated than that because it accounts for, the big thing that makes region very interesting, especially with Earth, is that it accounts for tilt. Whoa. Okay, so here's my simple, very cool effect. Say, one of the things that people often want to do is you got a bunch of stuff someplace, you got a bunch of stuff all over the place, and you don't want to show it all yet because that would be very cluttery. It can all be in one file, it can all be fetched, say it parses well, but it would just look really cluttered. You might have 10 cities in the world where you have something, and I'm going to show how we do this. You might put up, as I have here, a place mark with a point. It's just an icon which tells the user there's something here. And if you notice, the min LOD pixels value here is not set, so it defaults to 0, which means it's as if you hadn't specified anything. Therefore, this point's visible just like any other place mark. However, its max LOD pixels is set to be bounded at 256. So we can now think in terms of at about 1/8 screen area, this thing's going to pop out. But at the same time, I'm going to do some clever... Okay, see how max LOD pixels of one is the min LOD pixels of the other? This is a totally separate feature. Notice here I have my coarse grain feature with the point at the bottom. Here's my fine grain feature. Say I want to draw a big, huge polygon with lots of detail. I put that in a totally separate placemark. I reused that lat-long outbox exactly. And I changed the I set the min LOD pixels of the fine grain data to be exactly the same as the coarse grain. And due to the magic of how Earth computes its visibility, you get a completely clean swap. I tried playing with this originally by trying to do it with a hierarchy. And one of the difficulties with that is that it just so happened that the very first time I did this, I drew a box around Iceland. And then I subdivided that box, and I wanted to have more detail in the 4 subregions of the box that went around Iceland. But there was this gap of visibility between the main rectangle and the small ones. And the issue is that these are projected regions in 2 space. And as you move up towards the North Pole, those squares are not the same in screen space. Things work pretty well around the equator, but Iceland just happens to be far enough north that you get this issue. So then I decided, aha, you can just use the exact same lat-long outbox in 2 different features, adjust the min LOD pixels, and possibly the fade ranges you can overlap a little bit, and get a nice clean swap. Okay, quickly on Network Link. This is perhaps one of the power tools in the arsenal, which is used for hierarchies. Oh, somebody's coming up here again. I'll give you. Hello, hello, hello. Can you hear me now? Can you hear me now? Okay, good. So over time, we have produced some tools that we basically built to prove out the system. Those are all available to you. We've been steadily tweaking them and working on them. They're available here. Right now, you can go click on that and go see what that's about. A couple of the key tools there. If you have a CSV file of point data, this will build to your region network link hierarchy of it. If you have a whole ton of placemarks in a KML file, it parses out those and puts those in a hierarchy. And the tools that we actually use quite a lot internally for basically all the data that we publish are the 2 bottom scripts there, which walk your entire hierarchy and make sure that all the links are there, all the regions are the parents of children are the children of their parents, and that kind of thing. And my colleague Michael yesterday spoke about libKML, and it also has some region utility library, which we hope to expand on in the future, which we also use internally. So how many of you are familiar with the various layers in Google Earth? The Rumsey maps was sort of our first super overlay layer that's been out for a while now. Now we have a much larger set available. The gigapixel, gigapan photos came at some point in the last year. We started publishing the geolocations of the YouTube videos that we have that information for, book search, news, and my favorite is the weather. These are all 100% standard KML. And the thing that's interesting about that is you can build them too. There is nothing special that we do as far as how this data is constructed that you couldn't do. Any news site could host news in this way. Any weather site could do this. The Gigapan folks actually do host the KML for their Gigapan images, and so on. And I'll show some of those. Super overlay is a pretty interesting one. That's my favorite use of regions with network links, and that's been used in the weather, which we'll look at in a second, as well as very up-to-date imagery for some of the unfortunate events around the world, which have been helpful both to keep people up to date about what's happening in these places, as well as helping the people on the ground. One very cool thing about KML, we're at a web kind of conference. But as it turns out, you get into one of these disaster zones and there might not be web connectivity. Well, the very cool thing about KML is that it's just a bunch of static files. There is no fancy server-side infrastructure involved. So the exact same bundle of images and tiles and KML files that you might host on a server to serve to millions of users like we do from our servers could be put on a CD or on a laptop or on a thumb drive and used completely disconnected from the network. So you can take a satellite image, tile it down, as much storage as your laptop can hold. You can walk around with your own imagery for an area. And there's a rudimentary super overlay tool that comes along with the Regionator package. Okay, so let's review a couple of tips and tricks related to region. Min LOD pixels, that's your element. Think about how big you want. Think in terms of screen space. Think first about screen space. Don't think about, oh, it's really big because it's a country, or it's really small because it's a city. Think about the screen. Min LOD pixels is your element that's describing how much of the screen do I want to be, how big should this thing be on the screen before I bring it in and the other side for max take it out. But min LOD pixels is most likely going to be a number bigger than 128. Because if you think about it, 64 by 64 across a screen is a very big grid. If every one of those has a network link in it, you're firing dozens, if not hundreds, of network links, depending on the data set. Now, if you have that kind of server capacity, then go nuts. I know that we don't, so at least multiply by the number of users that we have. You can region with any feature. One of the tools in the Regionator base is something that will walk your region-based network link hierarchy, find every region there, and build a new region-based network link hierarchy, this time with screen overlays, giving you a nice kind of visual dashboard about what regions are active in your data set. When making imagery, there's a very careful, close relationship between the image tile and min LOD pixels. And the short of it basically is that the tile should be twice the size of min LOD pixels. One technique that we've used to improve performance is you can, of course, put many features inside of one file. You can wrap the images into a KMZ file. We generally either use 256 image tiles, pixel tiles, or 512. When we use 512 pixel tiles, then we'll use 256 min LOD pixels. And the reason is because that means that the largest extent for the intermediate range pixels will never stretch your data. If you set the min LOD pixels to the same as the image, you will always stretch your data. For only one moment will that data be non-disturbed, and you'll get the exact opposite effect of good quality, we'll just say. And again, as I said before, think in terms of 512 being basically the typical screen out there. Okay, so that's region. I'm going to rocket along here and talk just a little bit about time. I want to show some things just to make sure everybody sees what all this looks like. Not going to say too much about that. I'll show that. The bottom one there, check hide children. That's another one of my favorite little elements. Often you'll have either a network link hierarchy or you want to do something like, well, I want to have things in separate features, but I don't want to clutter up my left panel display. Check hide children is a way to basically collapse a folder hierarchy such that the user isn't bothered by a mess of hundreds or thousands or tens of thousands of links as can be gathered. That was the reason we came up with check hide children. One related to that is called check off only, and that means that if you do have a lot of data in your folder, you won't suffer the consequence of a user accidentally turning everything on by turning on the folders check. And if you notice, the Places panel uses essentially that feature. It just means that if the check is on, you can turn everything off, but you can't turn everything on. The user has to go inside and individually turn things on. Okay. Who here watched Santa Claus deliver the children their toys? Okay. Santa's pretty interesting for us. For the past few years, Santa has demonstrated and broken new ground in our KML technology. This year was the year that Santa was updated around the globe. So how many of you have used update for? Okay, update's kind of an obscure one. I think personally it's one to keep an eye on. There's some pretty interesting things that this can be used for in terms of incremental update of data between client and server, kind of in general. So there's some interesting things we're thinking about there. The concept basically is, here's the problem. Santa, really big sleigh, complex model. We're doing a 3D model now with all the reindeer. Takes a while to load that first time. Maybe it's a megabyte, I don't remember the size exactly. But you want to move it around. Before update, the only way you could do that is to refetch Santa. Well, you can't have tens of millions of people, children, whatever, fetching Santa Claus every few seconds. And they get bad performance that hits our servers, and it's the same sleigh every time. So update basically is the facility by which we can incrementally change any aspect of any KML that was fetched, such as, for example, the position of something. So this is a simpler example of an original KML file. In this case, it's a folder with a place mark. And here again is where ID is very important. Notice that the place mark has an ID. And it's a point with some description. And then here, again, trying to do my fancy display tricks here. This is update KML, which is within the network link control of another fetched file. And within change, you basically have a sparse KML expression, which refers to some KML that was previously parsed and operates on that KML in the user's computer. So now we have, instead of ID, we have target ID. And you can see that in this case, we are not actually changing the coordinates at all. That was my little copy-paste bug of the day. Obviously, this 3,42 could be any number you want. What happens is, it's as if that point is, it moves the place mark, it moves the sleigh, it moves whatever's there, it changes the name. Very powerful feature. The history of this feature is, this was released a little while ago now, but it was the proving ground for what is now the Google Earth plugin and its scripting. So again, there's some strong relation between these various aspects of the architecture of the language. Okay, here's another very specific tip and trick sort of thing that I'm going to try to show, and that is the use of cookie in network link control. So this is basically session state. And the one cool trick is, from KML point of view, it does not care what is inside of cookie. It can be whatever string you want to put there. However, if you use a name equal value type of notation, then on your server-side CGI code, you can use the regular forms parsing code to crack this thing open. And I'll show a little bit of code that does that. Okay, quickly now on extended data. Again, I talked about this is how you extend the custom data that might go along with the feature. For example, in our weather layer, every single one of the place marks in the weather layer has 50 data items associated with it, and those are all structured using extended data. And the powerful thing about that is we can design one weather balloon referring to whatever happens to be temperature, whatever happens to be the word for the visibility, and have a common design and only ship that file exactly once. Every single one of the 60,000 points can use that style, just filling in the blanks with whatever the temperature is there for that time. And one note, if in the past you had used the metadata element, that is now deprecated in the OGC standard in favor of the extended data element. Extended data is my favorite sort of low-tech element, and I encourage its use. We use it heavily. So I'm going to talk a little bit how the weather looks, and then quickly try to get to a demo. So a typical weather point is, how many of you have seen the weather in Google Earth? Okay, I want to make sure we show it again here in a sec. So you have points. Each point has a name. I'm giving you sort of the basic things that are inside of a point. And again, style, extended data is where all the data is. The point is, of course, where the coordinates of the point are. And another important thing that I'm highlighting here is that style references using style URL can, of course, be network shared. So all of our 60,000 points point to one style file, which means that you can have a big, huge style file, just like a big model, the same kind of, roughly the same sort of idea. It's fetched once, cached on the user's machine, so when they fly around the world and load whatever one of 60,000 or many of 60,000 points that they're triggering loads of, they're triggering files that are not that big. You could imagine if the style was in line, it would possibly double or triple the size of your file depending on what you're doing for your balloon style. Again, we make pretty heavy use of this. And this here shows one little teeny part of one of the coolest things about the extended data, and it's this notation down here. I wonder if I can do some highlighting. Oh, there we go. This right here, this expression here, means that you can reference any of the structured data items you've put in your extended data in your balloon template. And I've suggestively put these inside of HTML table elements. And that's exactly what we do for the weather balloons. And if you cracked open the weather balloons, you'd see that we have 50 of these things. And this is the extended data that's actually out in the element. This is something I just copy-pasted, as you can see, yesterday. We'll have the temperature. We had a big debate about how to do Fahrenheit versus Celsius, and we just picked both. Okay, we've talked about that. All right, so I'm going to do a demo, and first I will leave some time for questions. Finally, I'm going to close talking, though, about how things are enhanced in the future. So again, I spoke before about OGC standard. OGC owns KML. OGC is the only organization that can change KML. We are heavily active in the OGC, as are perhaps some of you. Some of us are actually going to their quarterly meeting. I'm getting on a plane tomorrow. They have a bit of a heavier weight mechanism for changing it, rather than us engineers just kind of typing at our keyboards and releasing whatever we want. Therefore, we have come up with this extension mechanism such that we basically can have our cake and eat it too. The intention is that we can continue to release extensions to the language in our products whenever we want, and anybody else can do the same thing. And the standard formalizes the means by which that is done. Future versions of the language are controlled by the OGC, and there are some processes being worked out now for how that occurs. So the key thing, again, from a developer's point of view is if and when such extensions appear, they will be namespace prefixed as per the OGC spec. All right, let's take a look at a little demo. First of all, this is probably going to be a little bit hard to see, unfortunately. One of the code site, we keep a bunch of KML samples on our code site. Maybe I can try to do something fancy here. No, I can't. Oh, yes, I can. Look at that. All right. So I'm going to act like Earth for a second. And I'm going to show what Earth sees from a teeny little script which makes use of update and the NetworkLinkControl cookie. All right, so this little script, I don't know if everybody can really see this. We'll just try it out. One of the things that I probably could have challenged people at the beginning was to give you the location of this little script and go beam it up to the new App Engine infrastructure and do this live. I'm running this from an Apache running on this machine. So when I fetch this file, in this case, I'm getting this NetworkLinkControl. It's kind of hard to scroll from here. There's a cookie and a placemark. So how does Earth process this when this link is refreshed? Earth does this. It's as if you had gone and typed the contents of that cookie as the query parameters. And now I fetch this. Okay. My script, when it sees that query parameter, goes, and if you were to see one thing here, you'll see that the cookie count is now 1. And that's just because my script has been written to say, oh, the cookie that I've just gotten is a query parameter, it's 0. I'm going to increment it by 1. And the next time I send something, I'm going to mark it as 1. When this is refreshed, that cookie just goes right back. And you can see now the cookie is 2, and we have some different data. I'm going to skip ahead to 3. Finally, we get to 7. Actually, let's go to 6. My cookie was 6. When I fetch that, it gives me 7. My clever little script, when given 7, goes back to 1. And if you're watching the coordinates and the names, you see that what we basically have done is a little tour around the world. That's how we move Santa Claus around the world. So that's me acting like the Earth client. Now I'll have Earth playing the role of Earth. Okay, this is a time-based network link, interval-based network link. If I wait some number of seconds, okay, at like a 6-second time interval. So if you were paying attention, this was number 1. Okay. So that's a quick look at how to use update and how to use a cookie and how to have dialogues appear on the screen. All right. I'm going to now just demonstrate some of the things that you can actually build with KML. A few months ago now, maybe longer than that, we introduced the weather. So this right now is the cloud cover on our planet. We are working with the Naval Research Lab for the clouds. These are the Navy's clouds. We get them once per hour. It's a mosaic of some satellite images. We get from them a giant TIFF, which is something like 9K by 4K. So, of course, that leads to use of super overlay. Overlays can be transparent. You can obviously see through the clouds and see the Earth. They can be put into region-based network link hierarchies, which this is, and they can be time-stamped. Which provides the effect of animation. So in the layer that we publish 24 hours of clouds. We have 6 hours of clouds animation. And this is quite simply just the combination of ground overlays arranged in region-based network link hierarchies. These ground overlays are actually interestingly named ground overlays, however they are at altitude. We draw the clouds up a little bit higher. You can fly under the clouds, basically. So here we are in the Caribbean, which looks like it's a little cloudy right about there. Have the clouds flying by overhead. So again, this is something that you can do too. There is no special Google Earth sauce in here. This is pure 100% OGC standard KML. If you have better clouds to publish than we, then go for it and use this feature. Another one of the layers that we released, now that we're looking here on the ocean, is the YouTube layer. YouTube has some number of points, I think approximately 1,900,000 or so points, all of which are published in a KML region-based network link hierarchy of points, the icons being the YouTube icon. The point being here is that this is a means by which you can publish very large amounts of information. We have many layers that have on the order of many 100,000 to 1 million points. And again, it's fetched the same way that levels of detail, all controlled. The books layer here is being shown, and we have the gigapan layer. I'll show one more thing, and then we can begin to take some questions. I'm going to fly into, how many of you played with Street View? Street View maps, you played with Street View on Earth? Street Views in Earth? Aside from it being a cool feature all in and of itself, one thing for relevance to this group is that this is also 100% KML. These icons are Placemarks. There was one, another little tip and trick here was that I'm clicking on these icons, and now I'm flying wherever. There's a balloon style now which allows you to disable popping of the balloon when somebody flies to that balloon. So that's how we made these features. We just put the points along. The points are, again, a region-based network link hierarchy of photo overlay elements, which you can navigate between. And of course, that's where we're now flying around outside on the street here someplace. There is an organization called Gigapan. If you go to gigapan.org, you don't need to be a billion-dollar company to take these images. If you have a consumer digital camera and $200, or want to buy an electronic kit, an open source form even, then you go to the Gigapan folks, and they have some free software. They can take a panoramic image. You can beam it up to their website, and some number of those images are also published as an Earth layer. Again, 100% KML. You can publish this stuff too. All right, we have a little over 10 minutes, which means I can now take some questions. I'll just start up a little graphic to have something cool on the screen. I can't completely see what's going on here. There are a couple of microphones here, and I'm going to make one little proviso is that the questions that I take or can answer are technical questions. Questions about, I can't predict the future, it turns out. So, but anything technical, bring your KML files up and we'll dig right into it if you like. Yes?
So you mentioned something about working offline, and I thought there was a 500 megabyte limit to how much data you could cache. I was wondering if that had changed or I misunderstood.
The data that's what you're referring to, there are many caches in the product. What you're referring to is the base imagery. You can load as much super overlay data in XML and JPEG files on your hard drive and load them in via KML. And KML itself has some degree of caching as well. But it's essentially not limited only by how much storage you have. And that's actually kind of a benefit of this feature.
Thank you.
Any more questions out there? Looks like we have some people.
I have a question.
All
Is
right.
there a Google Earth wizard that you can start with for a simple to create a Google Earth? Did that just come out recently? Like a wizard like they do for the Maps API?
I'm sure that this is, what is it you're trying to accomplish?
Do you want to create your first Google Earth mashup just in the same way that you would with
Oh, I see what you're
Map?
saying.
Yeah.
Earth, if you look up here on the panel on the top, has some built-in editing tools. So for example, here I want to make a place mark. Here I am here. Okay, so now I've made this place mark with a balloon. I can draw lines, polygons, basically the same primitives as my maps. And as far as from a language point of view, it's the exact same language underneath. So anything you draw in my maps, you can view here and the other way around.
How do you do that? So if I have a map, I did a map mashup, and how do I translate that to Google Earth, the KML?
In my maps, there's a button called View in Google Earth.
You in Google Earth?
There's a button. Press the button. What's going on underneath the scenes is a network link.
Does that work for all around the world? Because I think I was working on a U.S. map and I ran into problems with international.
Shouldn't be any No restrictions on that.
Okay, thanks.
I'm going to go to this side now.
Yeah, thanks. So if you export that placemark and actually look at the KML,
Yes.
you have a lot of style information in there.
Yes?
So can you explain like exactly what that style is? Because I think, you know, on face value, it just looks like one element and that's it. See how you have a bunch of different styles in there?
Uh-huh. I'm not going to try to, I can teach you a tutorial on this quickly. The key concept that's going on inside of this style, we'll just get right into code, is that you have three things in here. You have the style and a style map and two styles. And they are controlling, the style map controls the rollover behavior, and you can swap between any two styles. That's the short version of what's in there. And the effect is basically, notice that that's getting bigger. That is explicitly being defined by that style map. If you wanted to change the color, if you wanted to make it smaller, if you want to make it go away, that's done in you have a highlight style and a normal style. The style map switches between those two. So, yeah, thanks for that question. Yes?
In the feature you were just showing with the extended data and the styling of the balloons,
Yeah.
Is that there to save space?
Yes, absolutely.
And how much space do you think it saved for the weather feature, for example?
Totally depends on your data set.
Okay.
You can imagine, I mean, I'll show you our, here's the weather balloon. Actually, that's a book. Okay, so this basically has 50 items of data in it. Those take up some space. The formatting isn't really that complicated in this case. But given the layout, these icons are all standard. I mean, you can imagine having that all, the full balloon formatting in every single file. So it really depends on what you're doing. The key thing about the balloon style is that it's shared. If lots of features point to the same URL, it's not like they're each getting their own copy. It's fetched once. There are cache controls in KML that we make use of that you can set to cache that style for a week or something. And then as the user peruses their data set, you won't fetch the style. This arguably isn't that sophisticated a style, but at least it allows for this, a uniform layout. If you wanted to change all the backgrounds to green, you can do that with one file someplace. I'm going to switch to this side, yeah?
Is there an inheritance mechanism for style in container elements?
Style does not cascade, is the short version.
Yeah.
So there's no cascading. Every style of every feature is explicit via the style URL or the inline style elements, and those have a merging algorithm. Yes?
Hi. Could you please tell us a little bit about the KML streaming based on geo database backend like ArcGIS or PostGIS? What mechanism do they use? Or what kind of feature do they use within KML? Like KML streaming, what does that mean?
The short version is I don't know what those products do. I can tell you what's available in the language. I can imagine many different things that they would do. One thing that we do, for example, is, as I mentioned before, when somebody makes a MyMap online and exports it to Google Earth, the mechanism by which that's shared or exports it to the world is a network link. And as far as the specific features of the language that the product you mentioned makes use of, I'm not aware of what that's something you have to ask for them. Again, KML is now an international open standard, and how they use it for whatever purposes. Our Earth draws it all, whatever it is. So I'm going to go to this side, yeah?
Is region supported in KML for Google Maps API? And if not, is it planning to? And if not, how do you get big data sets into Google Maps?
Excellent question. The short version of that, it is not supported. The longer version is that we would love to support it. And again, this is my technical answers to questions. I can't talk about any kind of schedules or features. That's kind of an open area, actually, right now. If you look today on maps, just a couple weeks ago, we released this more layer. You can see basically layers on maps. So the whole concept of doing layers on maps is pretty pretty new for us. I personally would like to make sure that as we expose APIs and language extensions for this, that it's absolutely portable across, agnostic of the display system, whether that's Earth or Maps or your phone or whatever. So at this point, that's a pretty open area for some hard work to do.
Thanks.
Yes?
My question, using the regions with hierarchical layers of network links, what kind of tips would you suggest if you start to experience network delays where the user should see something popping up because of maybe the size of the data or the network speed, the client hasn't received it yet?
That's a big question. Question is essentially how to debug slow networks. Use bigger regions. If often in the data layers that we serve, we are having to make trade-offs between lots of fetches versus high bandwidth. And if you're having network problems or slow networks or flaky networks, maybe it's better to fetch larger data items, and in which case you'd scale the region to be larger. The short answer, there isn't any particular provision for retrying or such things. So it basically trusts that the network's there. I mean, the better answer might be that it's based on it's HTTP. So we're not doing anything more than whatever an implementation's HTTP engine is doing. Actually, one thing I'll add to that is make use of the cache controls. We do honor cache control headers. So, for example, these YouTube icons, the various suns and clouds and whatever, those we pass down as one big KMZ file in an icon pack. Those are never going to change. Those have probably been sitting on my machine for weeks, and that's a good chunk of data. So that's something else you might want to think about. Okay, we're still on this side.
Is it possible to host a KML file on a server and have multiple users edit it through Google Earth?
Of course, that's basically what's going on when you have a collaborative My Maps. The client has no awareness of how that file is being changed. So it's up to the client to refetch. Whatever it happens to fetch, if it's changed, then you get new data. One thing to mention with respect to how fetches work is kind of maybe a slightly low-level technical detail, is that by default, a network link fetch, and some people ask, oh, I do this network link fetch and it takes away my balloon. Well, actually what it's doing is taking away the entire feature. When you do a network link fetch, the first thing that happens is everything that it fetched before is destroyed. And the refetch fetches the data and just draws it again. So in a sense, that's pretty well behaved. The update feature is much more fine-grained. It won't destroy what's there from before. It'll just do an incremental change. So those are kind of the basic building blocks of how you might implement such a thing.
Thanks.
Does that help you? Oh, now we'll jump over here. Yes?
Thanks for the tip on the when you have lots of points of showing it at a coarse level versus a fine level, because that is a problem I do have. The question I have is the decision about what do you display at that coarse level. Anything in terms of tools that are, for example, making spatial selections so you only see the points you want, or is this a problem you just basically have to solve on your own?
We make a pretty low-level system. We have these conferences to talk about these low-level primitives, and everyone is welcome to help solve that problem. But that can be a very, very difficult problem to solve. Yeah. We worked for a bit. I don't know if you noticed, we ship a new version of 3D buildings. Those were all done originally with KML, and we had done some things where we would, at one level of detail, based on a region, fetch a lower resolution version of a model with maybe no textures or a single colored texture. As you get closer, you bring in a more detailed model, that sort of thing. But it's very data set dependent. That's a difficult problem to decimate a polygonal data set, for example.
Okay, thanks.
Okay, I think I have time for one more. And we're going to go to this side. I myself am going to be at our booth out here, so I'd be glad to talk more with people about their KML questions. in 15 seconds. Yes?
You have talked about the update tag and for the network link.
Yeah.
And one of the required argument that you have to specify the URL of that original KML.
Yes.
And if you're using a URL that goes to the servlet in your server, and you specify, if you change any argument there, like increment account or something, it will break that update. So what I mean, it has to be a static URL.
It's supposed to be just based on, it's the same model as the JavaScript security model. So it should just be host and path.
But if you, for example, if you add an ampersand, it will not work.
Now, I was just doing this with the code that's here now had a query string on it. Query string is ignored for that match.
Oh, really?
Yeah.
Oh. Okay. Thanks.
All right. I'm done. And again, I'll be out at the booth for more questions, and hope you enjoy the rest of the show. Thanks.